Friends, in today's lecture we are going to write 8085 program which subtract 8-bit data which is to be stored at memory location 3001 hex from the data which is stored at 3001 hex. So here we make subtraction of two 8-bit data. One is data are stored in consecutive memory location. First data which is to be subtracted is stored at 3001 hex, while data from which is to be subtracted is stored at 3000 hex. So our program statement is write an ALP to subtract 8-bit data at location 3001 hex from data at location 3000 hex, and the subtraction is stored at 3002 hex. Here in this program we make use of consecutive memory location 3000, 3001 and 3002. So as per our last lecture, I told you that before writing actual coding, first we have to write the algorithm. For this program also I am giving algorithm to you. So first step is start. Then as memory data is stored in memory, always remember that first we have to write initialization of memory. Whenever data is stored in memory, this is very important instruction. At least you will get 1 or 2 marks by writing this instruction. So first initialize memory to 3000 hex. Now this data is to be moved to accumulator because we want to subtract the another data from this data. So first the data is moved to memory to accumulator. Now increment the memory because our next data to be subtracted is at 3001 hex. So increment memory by 1. Next step is subtract this data from memory. That 3001 hex data will be subtracted from accumulator. Direct instruction is there. Now we want to store the result of subtraction in the next memory. So we have to increment the memory first by 1, and then that subtraction in accumulator will be moved to that memory location, and then we stop because we have to ask to store that subtraction only, nothing else. So these are 8 steps in algorithm. Now we are going to look how to draw the flowchart. So by using the symbolic representation, start, initialize to memory, then move data. So for move data we require parallel segment, increment memory, subtraction memory, that we use rectangle, again increment memory is there, and lastly output section. So move accumulator to memory and then stop. Draw flowchart like this. Now actually how does this coding will perform? Look here. First draw the table, memory address, label, mnemonics, opcode and description or comment you can say. So here as data is stored at 3000 hex, 3001 and 3002, I am choosing this memory location from A000 hex. You can choose any memory. Suppose you choose again 2000 hex, then the program all other memories contain 2001, 2002 like that. Now so our first instruction is initialization of memory. So we use LXIH and memory is 3000 hex. So LXIH 3000 hex is our mnemonics. Here opcode of LXIH is 21 and next memory location is 0030. Okay, first lower byte will be stored and then height byte will be stored. So we initialize memory first. It required three memory location, A00, A001, A002. The next we have to move this data in memory to accumulator. So move A comma M, 1 byte instruction. We are moving this first data to accumulator from 3000 hex. Now our next data is at 3001 hex. So we use increment memory. So INXH. It is also 1 byte instruction. So A004 hex will acquire this INXH, which opcode is 23. Now next, this data in this memory, INXH means now memory location is 3001 hex. So data from this 3001 hex should be subtracted from data stored in accumulator. So use subtract M, simple instruction, 1 byte instruction. So it will take one memory 8005 hex. It will subtract that 8-bit data in memory location 3001 hex from 8-bit data in accumulator. It uses 2's complement method and then store the result in accumulator. Flags are affected. So next we have to store this answer in memory 3002 hex. So we are incrementing memory again. So 1 byte instruction A006 hex INXH, 23 is the opcode for that instruction. After incrementation, just we have to move data from accumulator to memory. So A007 hex move m comma a. See here, in A003 we write move a comma m, that is memory to accumulator. Here move m comma a, that is accumulator to memory. In reverse order the flow of data is. So move our result, that is subtractions, in accumulator to memory location. And last one is restart instruction, to restart the processor for taking input and output. So in the next lecture we are going to write a program about 16-bit addition. Thank you.